right, so we're going to talk about limits first, and we're going to take a look at one-sided limits before we take a look at the overall limit. So here we're talking about limits, and they're just calling it intuitive approach. Notation is extremely important here. You need to make sure that you understand and are able to read this notation properly. So here it says, if the values of f of x can be made as close as we like to a given L by taking the x value sufficiently close to but not equal to A, then we write the following. Okay, this is a boatload of mathematical jargon here. So what are we talking about? So it says if you're given a function, okay, so this is our function which is represented here by this graph, okay? And they're saying if we can get these values super close to an A value, meaning some given x value, 1, 5, 3, negative 7, we're approaching our x value, so this is A that we're talking about right here, but not equal to, what we're looking at is the behavior of the function as our x value approaches that number, meaning what's happening to the y value. Are we going to, meaning is the graph approaching the same value, or is the graph approaching a different value from both sides? So that's what we would have to look at, and this is our L value. Okay, so this is read as the limit as x approaches A of f of x is equal to some given L value. Okay, or you could say the limit of f of x as x approaches A is equal to L. Okay, but you do need to know how to read it. Okay, one-sided limits. All right, so we're going to look at these first because when you're evaluating the overall limit of a function, that's what you're looking at. The behavior as we approach from the left and from the right. Is the behavior the same or is it different? Okay, so with respect to the right-handed limit, okay, if the values of f of x, meaning our function, our graph, can be made as close as we like to a given L value by looking at x values that are sufficiently close to a given A, but greater than, meaning from the right. So we're looking at greater than. You're looking here at this exponential plus. I know it's teeny tiny, but when you take a really close look at your paper, hopefully you'll see that plus. And what this is saying is we want to evaluate the limit of our given function f of x as x approaches a given A value from the right. We don't care what's happening on the left. We only want to see what's happening as we approach from the right, and it would be equal to L. On the other hand, if we have these values that we're trying to make sufficiently close to L, we're taking our A values that are less than. So we're looking at the A values from the left. Okay? So here you have this teeny tiny exponential negative. So it's the limit of the function f of x as x approaches some given A value from the left, don't care about the right at this point, is equal to L. Now, these two actually do play into one another when you're evaluating the overall limit as x approaches A, but you can evaluate a one-sided limit, meaning either from the left or from the right and not care about both together, or use that concept to evaluate, which is what you're supposed to do is you evaluate the overall limit. So here this says the limit of f of x as x approaches A from the left and from the right both exist if they are the same number, meaning the overall limit would exist. So what this is saying in English is if you have your left-handed limit and your right-handed limit, they both exist, meaning they're not undefined, okay, and they are the same given value for y, they're just using L to represent that, then the limit overall as x approaches A would exist and is equal to L. Okay, and I'm going to show you numerically what this means if you are unsure. Okay, now, if you approach your given x value from the left and it doesn't exist, meaning maybe it's approaching infinity, okay, it doesn't go to one specific value, and as you approach from the other side it goes to 5. Okay, if those values are different, then the overall limit doesn't exist, and that's what that next statement is saying. If either the one-sided limit doesn't exist or they go to different values, then the limit overall as x approaches A of f of x does not exist. Okay, so if you have a one-sided limit that doesn't exist, or they both exist but are different. Okay, so the biggest piece here is that in order for this limit to exist, both the one-sided limits exist and they have to be the same number. Okay, they must be the same. All right, so let's take a look at this graph here. All right, and I know, again, these are really small, so just do your best when you're looking at it. I will clarify. We're looking at the graph. This is some crazy piecewise function. Okay, and we want to evaluate the limit as x approaches -2 from the left only. We don't care about the right. So here we are at -2. We're approaching from the left. What is this value as we get closer and closer to -2 for x from the left? It's +1. Okay? What about when we're approaching -2 from the right? It is 0. Okay, so you notice how the left and right-handed limits are different? So if I were to ask you to evaluate the limit as x approaches -2 overall, what would you say? It does not exist. Does everyone understand why? Okay, the graph is not meeting up on either side. Okay, what about the limit as x approaches 0 from the right? It is 1. What about 2 from the right? Sure. 2 from the left? It is 0. Okay, so what about the limit as x approaches 2 overall? Does not exist. Okay, questions on that? Okay, and then what about the limit as x approaches 0 from the left? 1. Okay, so even though it's not on here, I wanted to point these out. We have f of 0, we have f of 2, and we have f of 4. I just want to talk about these really quick. So again, we're not talking about the limit. If we knew what the function was, we would be able to plug these corresponding x values of 0, 2, and 4 into the function and evaluate. But here I'm using a graph. So if I asked you to evaluate the function at 0, what's the answer? Why?
Because it's not, the circle is not filled.
That's right. So here, f of 0 is an open circle, meaning that point doesn't exist at all. So this answer would be DNE, or does not exist. What about f of 2? I see 2 points there. How do I know which one to choose?
The filled-in.
Yeah, the filled-in one. Okay? So in this case, the answer would be what? 3? And then what about f of 4? Do your best to approximate what you think it is. Did I hear 3? Maybe 3 point something?
3.8.
Approximately 3 to 4, we could say. Here, because there's not a grid, this would be an ambiguous question. We would probably pick something that was a little bit more obvious. If you gave me 3.5 because you were unsure and you were looking for an exact value, I would take it. Okay, but does everyone understand how to evaluate and read the graph? Awesome. Okay.